Hello everyone. This side you need to find some point where function is breaking. The point at which your function breaks basically describes discontinuity. So let's read it. Many functions have the property that they can trace their graphs with a pencil without lifting the pencil from the paper surface. These type of functions are called continuous. Intuitively, a function is continuous at a particular point if there is no break in the graph at that point. That's what I told you. Function is continuous at a particular point if there is no break in its graph at that point. Okay, so a precise definition of continuity of a real function is provided generally in calculus introductory course. First, a function f with variable x is continuous at the point A on the real line if the limit of fx when x approaches the point A is equal to the value of fx at A, which means if I write it in mathematical form, so limit of x tending to A f of x should be equal to f of A. Okay, so this is the basic meaning of continuity. So basically what continuity means when you are approaching some point either from left or from right, you are approaching some point, so the value of function at this point should be equal to the value of limit at that point. So this is very important thing. Basically both left hand limit and right hand limit and the value of function at that point, which is f of A, or if all these things are equal, then only you can say that a function is continuous. Otherwise a function is not continuous. So let's say this is a function and you want to find continuity at this point. So what you need is left hand limit, which is coming from this side, right hand limit is coming from this side, and the value of function at this point. All these three things, if they're equal, then you can say that your function is continuous at that point. Otherwise it is not. Okay, so let's move ahead. Mathematically, continuity can be defined as given below. Firstly, fa should be defined, then limit should exist, and this limits LHL equal to RHL and should be equal to the value of function at that point. So firstly, value of function should be defined at that point, limit should exist at that point, and the value of limit should be equal to the value of function at that point. Okay, so इसको हम लोग ऐसे भी बोल सकते हैं that a function is said to be continuous if you can trace its graph without lifting the pen from the paper. But a function is said to be discontinuous when it has any gap in between. Okay, so this was an easy definition. Moving ahead, now let's move on to limits. So what's the definition of limits? Limits is something like a limit of function is a number that a function reaches as an independent variable of function reaches a given value, which means let's say your x is tending to A, let's say your x is tending to A, then your f of x should tend to f of A. Okay, so this is the basic concept behind limits. मतलब अगर आपका जो independent variable है that is tending to some point, then the value of a function which is dependent on this independent variable should also tend to the value of function at that point. If this thing exists, then your limit exists at that point, otherwise it is not. So I hope you got it. So the value to which the function gets close arbitrarily as the value of the independent variable becomes close to that point. So points to remember: if limit of x tending to a minus fx is expected value of f at x equal to a, gives the value of f near x to the left of a. This is known as the left hand limit. Left hand limit is similarly going to a function from the left hand side to a point from left hand side. Right hand limit is going to a function from right hand side, and if left hand limit and right hand limit are same, then only you can say that the limit exists at that point, which means let's say you want to define limit at some point A. So what you will say? You will say that limit of x tending to A plus f of x should be equal to limit of x tending to A minus f of x. ओके, विच मीन्स कि आपकी जो लिमिट है वो आप चाहे लेफ्ट से आ रहे हो चाहे राइट से आ रहे हो, दोनों जगह से इफ यू आर कमिंग टू सम पॉइंट देन योर लिमिट वैल्यू शुड बी सेम, देन ओनली यू कैन से योर लिमिट एग्जिस्ट एंड द वैल्यू ऑफ लिमिट इज इक्वल टू द लिमिट is equal to either of these two because both of them are same only. So this is the basic concept of limit. In continuity, just one thing adds to it: this both limits should be equal, and this should be equal to the value of function at that point, which is equal to f of a. in case of continuity. Okay, so this was about limits and continuity. Moving on to some properties. So, one second. Okay, so moving on to some properties. Limit of a function is represented as fx reaches L as x tends to limit a such that limit of x tending to fx is equal to L. The limit of सम में हम लोग लिमिट को ब्रेक कर सकते हैं. लिमिट इज डिस्ट्रीब्यूटिव ओवर सम. लिमिट ऑफ x tending to a fx plus gx is equal to limit of x tending to a fx plus limit of x tending to a gx. Okay, then limit of a constant function is that constant term only, and similarly when we multiply scalar by limit, then that scalar comes out and limit goes to the function itself. Quotient rule also, that we can apply limit individual to both of them, provided that limit of x tending to a gx, which is the denominator, this should not be equal to 0. Because we know that whenever we divide something by something, the denominator should not be equal to 0. Otherwise, it is not. Otherwise, it will not exist. That's why limit of x tending to a gx, limit of x tending to a gx should be equal to, should not equal to 0 if we want to distribute limit over the division part. Okay, so I hope you got it. Let's move ahead. One second. Okay, so moving on to differentiability. So what is the concept of differentiability? Differentiability is something like this. You define differentiability by this. F dash of a is equal to limit of h tending to 0, f of a plus h minus f of a divided by h, where h is where 0 can be 0 minus or 0 plus anything else, anything. So this is the basic definition of differentiability. So if you want to calculate the differentiability at some point, you just need to apply this formula and you will get the value. So those are the some one thing more. If a function is differentiable at some point, then it must be continuous at that point, but vice versa is not always true. This thing I have told you many a times, that differentiability automatically implies continuity, but continuity does not imply differentiability. मतलब क्या है? मतलब ये है कि अगर मेरा function is continuous, it is differentiable at some point, then it will be continuous at that point, because differentiability comes only after continuity. It is something like going to third class, but for going to third class, you need to cross PG, LKG, UKG in first and second, then going to third class. So differentiability will come only after continuity. So if a function is differentiable, then it is continuous. But if a function is continuous, it is not necessary that a function is differentiable also. Okay? So this is a very important thing, because sometimes it is asked to you in questions that tell if the function is differentiable or continuous or not. So if you check for differentiability first and you got that the function is differentiable, then you don't need to check for continuity, because differentiability automatically implies continuity, but the vice versa is not true. Okay, then derivative of some basic trigonometric function is given: sin x ka cos x minus sin x, tan x sec square x, cot x minus cos x square x, sec x tan x, cos x minus cos x cot x. So these are some basic derivatives which you should remember. Okay, now moving on to some important limits. These are also important ones. So please remember these things. Limit of x tending to 0, sin x is 0 because sin 0 is 0, cos 0 is 1. So this is 1. These one are important ones, very important actually. Limit of x tending to 0, sin x upon x is equal to 1. And if you, when you reverse this thing, then also it is equal to 1. Very important limit. Same goes with tan x. Limit of x tending to 0, tan x by x is equal to 1. Or you invert them, then also it is equal to 1. So these two are very important. Then this is also limit of x tending to 0, log of 1 plus x by x is also equal to 1. Similar with e power x. And this one is also important. Limit of x tending to 0, e power x minus 1 upon x is equal to 1. This limit will be used many a times in calculating log questions. So this is also important one. When you replace e by a, then you will get log a. Why? Because it is log e only, and log e is equal to 1. इसको आप लोग log a लिख सकते हो ना. So this is basically, this formula is basically this formula is basically from this formula only. You just take here a equal to e, so you will write log of e, log of e only, and this thing is equal to 1. That's why it is 1 only. So the basic formula is replacing e with a, so you will get log a. So these are the two limits formulas. Then log of x tending to infinity. So don't remember it in this form, remember it in this form, that 1 plus something which is tending to 0, because 1 upon infinity is something which is tending to 0. So limit of something such that 1 plus something tending to 0 power infinity. It is, remember it in this form: 1 plus something 1 plus something tending to 0 power something tending to infinity. This thing is equal to e power something tending to 0. Okay, so here something tending to 0 is e power this thing, your power which is something tending to infinity multiplied by something tending to infinity. Okay, so we have to just multiply this power with this thing and raise it to the power of e. So here if you will multiply x and 1 by x, you will get 1 only. So it is e power 1 which is equal to e only. So please remember it in this form. This is very, very, very important property. Limit of something such that 1 plus something tending to 0 power infinity is e power something tending to 0 multiplied by something tending to infinity. So 1 by x into x is 1 in this case. So here you are getting e only. Okay. Then limit of x tending to a into constant function, this is equal to a only. So I hope you got it. Okay. So kfx and k will come out. Some it will break over sum and division, sum and subtraction, then multiplication, division, and then this thing is also this is not as important, but I should know. And then you can change the limit in this form, all those things. Then again the same properties, limit of x tending to 0, sin x by x is equal to 1, cos x is equal to 1, tan x by x is equal to 1 minus cos x by x is equal to 0. This is also important property. Then sin x by x, not important. Remember, forget this. This is very important property again. Limit of x tending to x power n minus a n upon x minus is equal to n a power n minus 1. From here only the definition of that differentiation grows. So please remember this thing. Then this one I told you, a power x minus 1 is equal to ln a, e power x minus 1 is equal to 1, ln 1 plus x upon x is equal to 1, and x, this is also important. This will directly used in questions, infinity power 0. Infinity power 0. So this thing is equal to 1. Again, important one. So please remember this thing. Okay, so moving on to one of the most important rules out there in the chapter limits. If you don't know this rule, then many of your questions you can't solve because this is a very important one. So what this rule says that if you have some question in which you have been given fx upon gx, what? Fx upon gx, and limit of this is tending to some point, limit of x is tending to some point, you can take any point. If this thing is indeterminate form, which is indeterminate means not defined. Some of indeterminate form I will tell you in coming slides. So if this is indeterminate, then the limit value is nothing but you just do differentiation of both. But remember, you are not doing the differentiation of this thing. You are not doing differentiation of something divided by something. You are differentiating it uh, respectively numerator and denominator differently. So basically, you are doing f dash x upon g dash x. You are not doing the differentiation of fx upon gx, but you are differentiating it alone. That is f dash x upon g dash x. So this is again a very important property. And from here, if you are doing this and you are again getting an indeterminate form, then you can again differentiate it. And you can write it equal to limit of x tending to a f double dash x upon g double dash x is equal to f triple dash x upon g triple dash x. So you can go it in this form only. The condition is only this thing that this should be equal to some indeterminate form. Okay, and again I'm telling you, you are not differentiating this whole thing. Like, you are not differentiating fx upon gx, you are doing f dash x upon g dash x. So please remember this thing. Now moving ahead. These are some indeterminate forms, like 0 by 0 is indeterminate, infinity by infinity is indeterminate, 0 into infinity. Why? Because 0 by 0 is you don't know it is 0 or infinity. Infinity by infinity, again, you don't know. It can be 0 also, it can be infinity also. 0 into infinity, infinity minus infinity, 0 power 0, 1 power infinity, infinity power 0. If you will get these forms, then these are indeterminate forms. In these cases, you can apply L'Hopital theorem. Okay? So, one more thing, the name of this thing is not L'Hospital, it is L'Hopital. L'Hopital. Okay. So moving ahead. Okay. So moving on to this question, limit of x tending to 1, 2x minus 3 multiplied by root of x minus 1 upon 2x square plus x minus 3. So how to solve it? Just do one thing. Make the factors of the denominator 2x square plus x minus 3. So how you can do this thing? You can just do one thing. multiply the firstly make its factors, it will be x minus 1 into 2x plus 3, and then multiply it by root x plus 1 upon root x plus 1. Why? Because what you need to do is when you multiply it with root x plus 1, then x minus 1 will get cancelled. So from here you will get 2x minus 3 upon 2x plus 3 into root x plus 1. And from here you just put the value x equal to 1. You will get 2 minus 3 minus 1. X minus 1 will get cancelled out with these two. And 2 plus 3 is 5 multiplied by 1 plus 1, 2. So the answer would be minus 1 by 10. Okay. Then question 2. In question number 2, it is saying if f9 is equal to 9 and f dash 9 is equal to 4, these two things are given to you, then you want to calculate this thing. Okay, so see, f9 is equal to 9. So here you are getting root of 9, which is 3. 3 minus 3 upon 3 minus 3. So what you are getting 0 by 0 form. You are getting 0 by 0 form, which I just told you it's an indeterminate form. So to solve indeterminate form, you need to differentiate numerator and denominator. So differentiation of numerator would be this is something inside the root. So in differentiation of root is 1 upon 2 times root x into differentiation of this root, which is f dash x, upon differentiation of this thing, which is again 1 upon 2 root x minus 3 का differentiation हो जाएगा 0. So now put x equal to 9 here. So you will get f dash 9 upon f dash 9 upon root of f9 upon 1 upon root 9. So f dash 9 is given to you as 4. So just put the values. 4 upon root of 9 is equal to 3. So 4 upon 3 divided by 1 upon 3. So 4 is your answer. So this is a basic application of applying L'Hopital rule. Again, this is L'Hopital only. And why you applied L'Hopital rule? Because you are getting 0 upon 0 form, which is an indeterminate form. And to solve indeterminate form, we already know that solving indeterminate form requires your basic understanding of what are indeterminate forms, which is indeterminate because you don't know that the answer would be 0 or infinity. That's why it is indeterminate. So I just differentiated numerator and denominator and I got the value as 4. That's my answer. Okay. So I hope you got it. Let's move ahead to this question. Question number 3. What they're saying limit of h tending to 0, a plus h square sine a plus h minus a square sine a upon h. So you need to do this thing. So let's do this thing. Firstly, do this thing. Let's say apply 0 here. So you will get what? You will get a square into sine of a square sine of a minus a square sine of a divided by 0. So you are getting 0 by 0, which is again in indeterminate form. So again, to solve this thing, you can't solve this thing, so you need to apply L'Hopital rule. So you have to differentiate numerator and differentiate denominator. So differentiating numerator will give you what? Differentiate it, so you will get 2 times a plus h into differentiation of a plus h would be 1 only because both are constants. Multiplication of sine of a plus h plus a plus h square as it is into differentiation of sine would be cos and minus differentiation of this thing a square sine a. And a and sine a both are constant, so इसका differentiation आ जाएगा 0. So differentiation of this thing upon differentiation of h again constant, it would be 1 only. So now put the value h here. So this would be a plus 0 into sine a plus a plus cos a. So you will get what? You will get 2a sine a plus a square cos a. So this is your final answer to this question. It's fairly simple question again. You have to just apply L'Hopital rule and you can do your calculations. Okay. So this was question number 3. Simply applying L'Hopital rule. It is something like limit of x tending to some function fx upon gx. This thing, this thing is indeterminate, if this thing is indeterminate, then this thing is equal to f dash x upon g dash x. Okay, and similarly you can move it ahead also, like sorry, like if this is also indeterminate form, then you can write it equal to f double dash x upon g double dash x, and so on. You can move ahead. Okay, so this is one thing. Then this was the simple orbital rule question. Then moving on to question number 4. So in this question, it is given to a limit of x tending to pi by 4, root 2 cos x minus 1 upon cot x minus 1. So in this question, what you did is you just need to apply again, apply pi by 4 here. So cos pi by 4 is 1. So 1 by root 2, so you will get 1 minus 1 divided by cot pi by 4. Cot pi by 4 is 1 only, so 1 minus 1. So you are again getting 0 by 0 form. 0 by 0, which is again an indeterminate form. So that's why you will again apply L'Hopital rule here. So applying L'Hopital rule, differentiate numerator and denominator. Root 2 cos x differentiation is minus root 2 sin x, because cos x का differentiation होता है sin x minus sin x, and differentiation of minus 1 is nothing but 0. So from here you will get minus root 2 sin x upon differentiation of cot x is minus cos x square x minus cos x square x. Okay, so you will get minus cos x square x, root minus root 2 sin x upon cos x square x. Now put the value of sin pi by 4. Sin pi by 4 is 1 by root 2. So minus root 2 into 1 by root 2 divided by minus root 2 square. So from here you will get what? You will get equal to minus 1 upon minus 2. That is equal to half. So half is your answer. Okay, fairly simple. Again, the application of simple L'Hopital. Okay, moving on to this question. And what it is saying, solve limit of x into 0, x upon tan inverse 2x. So again, now we need to do something with inverse functions. So let's say how to solve inverse functions. For solving inverse function, let it something equal to theta or something. Let's say a. Okay. So here I am letting it equal to theta. So what I am saying tan inverse 2x equal to theta. So from here, what you can say? You can say 2x equal to tan theta. 2x equal to tan theta, and x equal to tan theta by 2. Tan theta by 2. That's what it is written here. And since we are extending to 0, so at extending to 0, theta will also tend to 0, because tan theta equal to 0 implies theta equal to 0. So that's what it is written here. Limit of x to 0, x would be equal to half tan theta upon 2. So I put tan theta upon 2 divided by theta. So since I've changed my variable from x to theta, so here I can come back to my original trigonometric functions, because I don't know how to deal with inverse trigonometry. So I just changed my functions from inverse trigonometry to trigonometry. So I wrote x equal to tan theta by 2. So x equal to tan theta by 2 divided by theta. From here, theta is tending to 0, because when x tends to 0, tan theta is equal to 0, which implies theta is tending to 0. So half tan theta upon theta. From here, theta is tending to 0. Tan 0 is nothing but this thing. See this thing. You can write this thing as, I've told you the scalar will come out. So scalar came out, and you are writing half limit of theta tending to 0 tan theta by theta. And this limit I just told you in the results. This is your standard limit, and this limit is equal to 1. This limit is equal to 1. So this thing is nothing but, this thing is equal to half multiplied with 1. So your answer is equal to half. Okay, so please here do that. Please remember the application of this thing. Tan theta upon theta, limit of theta in this thing is equal to 1 only. So you took the scalar out and you did the appropriate calculations, and you got equal to half. Okay, so I hope you got this. It was not difficult. It was very easy. You have to just need to calculate it clearly, and you will get your answer. Then moving on to this question, question number 7. What it is saying it is limit of x tending to 0, tan pi by 4 plus x thousand by x. You need to solve this question. Okay, again, simple question, solve it easily. How you can solve it? Simply open this thing. The formula for tan of a plus b is tan of a plus b. This thing is equal to tan a plus tan b, tan a plus tan b divided by 1 minus tan A tan B. Okay, so from here you just put A equal to pi by 4, tan pi by 4 is equal to 1 plus tan x upon 1 minus tan x. So you are getting this thing. So what you can do is you can add 1 and subtract 1. Why? Because we know that tan 0 is 0. So this thing is 1 plus 0 upon 1 minus 0. This thing is 1 minus 1. So this thing is tending to 0. This thing is tending to 0. Power 1 by 0, which is tending to infinity. So this form is something like 1 plus something tending to 0 power something tending to infinity. And I told you how to solve this thing. This thing is nothing but this thing is equal to e power this something tending to infinity multiplied by something tending to 0. So just do it in this form only. So this thing is equal to e power 1 by x multiplied by something tending to 0, which is this thing. This whole thing is tending to 0 now. So 1 plus tan x minus मतलब इसको मैंने कैसे लिखा इसको ऐसे लिखता हूँ 1 plus tan x minus this thing. I just took the LCM minus 1 minus tan x sorry plus tan x divided by 1 minus tan x. Okay, so from here 1 and 1 will get cancelled and you will get 2 times tan x divided by 1 minus tan x. Okay, so that's what we get here. So I just multiply it 1 by x into 2 tan x upon 1 minus tan x. Okay, now just put the values. मतलब इसको you can write in this form 2 multiplied with tan x by x into 1 upon 1 minus tan x. Okay, and you again know limit of x tending to 0, tan x by x is equal to 1, as I told you in previous question. So this will equal to 1 and this will be equal to e power 2 and tan 0 is 0, so it will be 1 only, so e power 2 is your answer. Okay, so fairly simple question, not simple actually. You need to just you need to know how to solve this question. Firstly, you open the formula of tan a plus b. So you got tan a plus tan b upon 1 minus tan b. Then you wrote it in the form of 1 plus something tending to 0, power something tending to infinity. So you just added 1 and subtracted 1. So this form got equal to 0. So then you applied the formula. This thing is equal to e power the limit multiplied by the something tending to infinity into something tending to 0. Then from here you got the some basic tan x by x formula. So limit of x tending to 0, tan x by x is equal to 1. So this thing got eliminated as 1 and then you simply put the value 0. Tan 0 is 0 only. So 2 upon 1 is 2. So your answer is equal to e power 2. This is your final answer to this question. Okay. So I hope you got this. Got this. This was actually simple. Moving ahead to question number 12. So in question number 12, what it is saying? It is saying, okay, so this question is from continuity or discontinuity thing. So how to solve this question? Fx is given to you. This thing is equal to x square minus 4x plus 3 upon x square minus 1 and this thing is equal to 2 if x is equal to 1. So if x is not equal to 1, because at x equal to 1, this thing is 1 minus 1, 0. So you are getting indeterminate form. That's why when x is equal to 1, this thing is equal to 2. And when x is not equal to 1, then fx is equal to this function. So you need to calculate if the function is continuous or discontinuous. So with in these type of questions, what you need to do is you need to find the point where you can suspect. So here you can only suspect at point x equal to 1 because definition of function is changing at x equal to 1 only, no? So you have to check if the function is continuous at x equal to 1 or not. Because if function is continuous at x equal to 1, then it will be continuous at every point, because this is a polynomial function, and we know from our basic understanding that polynomial functions are continuous everywhere. So this function is continuous everywhere. And 2 is a constant, so 2 is also a continuous function. So basically, only you need to check on x equal to 1, because at x equal to 1, the definition of function is changing. So if your function is continuous at x equal to 1, which is a point of suspect, then only you can say that your function is continuous in the entire domain. So let's check it at x equal to 1. So how to check continuity? You have to take limits, limit of x tending to 1 minus, limit of x tending to 1 plus, and function of value at that point, value of function at that point. Sorry. So fx is equal to this. So for x equal to 1, f1 is equal to 2, this thing is given to you. Then you will check for x tending to 1 plus. For x tending to 1 plus, you will check, and for x tending to 1 minus, you will check. So 1 for 1 plus, limit of x tending to 1 plus x square minus 4x plus 3 upon x square minus 1. Okay, now you will put the values, on putting the values, you will get 1 minus 4 plus 3, which is 0, upon 1 minus 1 is again 0. So you are getting indeterminate form. So to solve indeterminate form, what you will do, you will differentiate both these things. You will differentiate numerator and denominator individually. So the differentiation of numerator would be 2x minus 4. 2x minus 4 upon 2x. You will get what? You will get 2x. Sorry. You will get 2x minus 4 upon 2x. Now put the value of x equal to 1. You will get minus 2 upon 2, which is equal to minus 1. Okay. Now check for 1 minus. Again for 1 minus, you will get the same thing, because nothing will be changed. So here also you will get minus 1 only. But the value of function at x equal to 1 is equal to 2. So basically your limit of x tending to 1 plus f of x is equal to limit of x tending to fx is equal to limit of x tending to 1 minus f of x. So this condition implies that limit exists at x equal to 1, because LHL is equal to IHL. But it is not continuous, because this thing is not equal to f of 1. You know that लिमिट के लिए अपने को सिर्फ यही चाहिए कि LHL should be equal to IHL. So here LHL is equal to IHL. So that implies that my limit exists at x equal to 1. But since this value of limit is not equal to value of function at x equal to 1, so we can't say that my function is continuous. So that's why my function is discontinuous at x equal to 1. It is such that limit exists at x equal to 1 because both the limits LHL and RHL are coming to be equal. Here my LHL is coming equal to IHL. So I can say that my function is limit exists at x equal to 1. But since the value of limit is not equal to value of function at 1, so I can't say that my function is continuous. Okay. So I hope you got it. Let's move ahead to this question. The number of values of x belonging to 0 to 2 at which fx equal to this thing is not differentiable. मतलब मेरे को वाले पॉइंट ढूंढने जहाँ पे मेरा फंक्शन डिफरेंशिएबल नहीं है. Okay, so सबसे पहले I know that the graph for mod x, the graph for mod x is something like this. Okay, and since it is given x equal to half, so when I put x equal to half, I will get 0. So my graph would be shifted by x equal to half. So my new graph would be something like this, where this point is half. Okay, so my function, this thing is mod of x minus half is not differentiable at x equal to half because we are getting a sharp point. So one point is at x equal to half from this thing. Similarly, for x equal to x minus 1, I will get a point at x equal to 1 where it is not differentiable. So I will get 1.1 point from here. And tan x is not differentiable at what points? The graph of tan x is something like this. So my tan x is differentiable at each and every point, leaving pi by 2. So my tan x is continuous in 0 to 2. Okay, I want to check in 0 to 2 only. No, okay. So my pi by 2 is what? Pi by 2 is equal to 3.14 divided by 2. So it is something in 1.5 something. So it is between 0 to 2. So I will take pi by 2. But next point would be, this is pi by 2, this is pi, this is 3 pi by 2. So next point would be 3 pi by 2. And 3 pi by 2 is something around 4.5. So this will go out of my range of 1 to 2. So I will not take this point, I will only take pi by 2. So tan x would be differentiable at one point, which is pi by 2. So from here, I'm getting 1 point from here, x equal to half. I'm getting 1 point from here, at x equal to 1. And I'm getting 1 point of non-differentiability from here at x equal to pi by 2. So at these 3 points, my function is non-differentiable. So I can say that my function is non-differentiable at 3 different points. Okay, so I just calculated the non-differentiability individually from these three, and I added all those things. So for x minus model x minus half, at all of the points, my function is differentiable, leaving sharp points. So from here, I got 1 point of non-differentiability x equal to half. I got here from here 1 point of non-differentiability at x equal to 1. Like it would be something like this. This thing is equal to 1. So this point is non-differentiability point. Similarly, for tan x, I got this point pi by 2 because at pi by 2 my function is non-continuous, and if it is not continuous then it is not differentiable. We know that differentiability is only when my function is continuous. So for tan x, I got pi by 2. So I got 3 points, one from here, 1 from here, and one from here. So at 3 points, my function is not differentiable. So answer will be C part. Okay. So moving ahead, which of the following functions have a finite number of points of discontinuity? Okay, so अब मेरे को यहाँ पे बताना है कि इसमें से कितने functions के पास finite number of points of discontinuity है. Okay, so tan x का तो मैंने आपको अभी बताया, tan x is differentiable at all pi by 2 points. Like whenever my x is equal to pi by 2, 3 pi by 2, 5 pi by 2, that is at all multiples of pi by 2, my function is discontinuous. So tan x would be the right answer because I know that this has finite points of discontinuity at x equal to odd multiples of pi by 2. And odd multiples I write in the form of 2n plus 1 where n belongs to integer. Okay. So I hope you got it. Then moving on to x into GIF of x. So x into GIF of x would be discontinuous at what points? I know that my x is continuous and my GIF of x would be something like this. If you don't know the graph of GIF of x, it is something like this. From 0 to 1, from 1 to 2, from 2 to 3, from 3 to 4, similarly from -1 to 0, from -2 to -1. So my GIF of x is discontinuous at all integers. This is a -1, this is 0, this is 1, this is 1, this is 2, this is 3, this is 4. So my GIF of x is discontinuous at all integers. So this is continuous, so no worries from here. So we have to only, my function will become discontinuous only because of this thing. So my function is discontinuous when x is equal to k, when x is equal to integer. So this is integer at all integers. This is discontinuous at all integers. This is discontinuous at all odd multiples of pi by 2. Then moving on to mod x by x. Mod x by x is something like, we know that this thing would be discontinuous when my x will become equal to 0. That is only at one point when my x will become equal to 0. At all the points, this function would be continuous because mod x by x will be something uh, polynomial only. My all the above functions have an infinite number of points of discontinuity, but mod x by x is discontinuous when x is equal to 0 only because mod x by x mod x by x is equal to 1 if x is greater than 0, and this thing will be equal to -1 if x is less than 0. Okay, so इसका graph कैसा आएगा? Its graph will be something like this. When x is less than 0, this thing is equal to -1, that is this thing. And when x is greater than 0, it will be something like this. X equal to answer will be 1 only. So at this point, there is discontinuity. and this point is discontinuity. Because at x equal to 0, you are getting 0 by 0 form, which is indeterminate. So this thing is discontinuous only at one point, which is x equal to 0. Mod x by x is discontinuous only at x equal to 0 only. Okay, so these tan x differentiable at infinite number of points at all odd multiples of pi by 2. X into GIF of x into GIF of x is discontinuous at all integers. So integers are also infinite. So this is also differentiable at non-differentiable at infinite number of points. Talking about sine pi x, then we know that sine pi x graph would be, because it is sine GIF of pi x. So again, since it is GIF of pi x, so we know that GIF is discontinuous at all integers. So sine GIF of pi x will also be discontinuous at all n pi x points, because since it is composition of two functions in which one function is discontinuous at all integers, so this will also be discontinuous at all integers when n pi x become equal to integer. So because obviously बात है ना कि अगर I am applying sine on some function which is discontinuous at all integers, so my sine function will also become discontinuous at all integers, and again integers are infinite in number. So all my points a, b, and d are discontinuous at infinite number of points, but my option C is discontinuous only at x equal to 0, and this is only asked to me in my question. They are asking me that how many points among A, B, C, D, which one is the function in which points of discontinuity are finite. So only at my option C has finite number of points of discontinuity, which is only one, which is equal to x equal to 0. All others have infinite number of points of discontinuity. That's why my function is discontinuous at x equal to 0 only in point option C. So option C is my right answer. Okay. So I hope you got it. This was a pretty simple question, but you have to apply brain in discussing this GIF of x type of functions. So if you don't know, then GIF of x is discontinuous at all integers. Please remember this thing. Okay. So moving on to next question. In this question, they are saying the set of all values of b for which f(x) is a maximum value at x equal to 1. Okay, so मेरे को बतानी है कि b की I tell the values of b for which my maximum value for which my fx is maximum value at x equal to 1. So again, we can check the suspect point is x equal to 1 only, because my definition is changing at x equal to 1 only. So what I need to do, I need to calculate f of 1 plus and f of 1 minus. So f of 1 minus would be calculated from here, because it is for x less than 1, and for x greater than 1, this thing is this. So I will calculate f of 1 minus from this definition, and I will calculate f of 1 plus from this definition. So what I need is, I need that fx is a maximum value at x equal to 1. So it should go like this, and at x equal to 1, it should turn like this. So basically f of 1 minus, which is this thing, and this is f of 1 plus. So f of 1 plus should be less than f of 1 basically, because I'm saying that at x equal to 1, my fx is a maximum value. So I am saying that f of 1 plus should be less than equal to f of 1. Okay, and this thing also and should be less than equal to, and this thing should also be less greater than equal to f of 1 minus. Basically what I'm saying is, मेरा function जो है उसकी maximum value 1 होनी चाहिए. Okay, so that's what I said. I calculate f of 1 plus from this definition. I will get minus 2 plus log of b square minus 4. This thing should be less than equal to f of 1, and 1 is included in this definition. So this thing should be less than equal to 1 minus 1 plus 10 minus 7, which is equal to less than equal to 5. I took minus to that side. I got log of b square minus 4 should be less than equal to 5. Then from here, I know that solving log, I will take 2 power both sides. So I will get, from here I will get b square minus 4, and from here I will get 2 power 5. 2 power 5 is 32. So my b square minus 4 is lying between 0 and 32. So solving this, I will get my b to be equal to, it belongs to minus infinity to minus 2 union 2 to infinity. And b square minus 36 is less than equal to 0. I will get b should lie between minus 6 and 6. So I need to take the intersection of both of these domains. So on taking intersection, my final answer would be from minus 6 to minus 2 union 2 to 6. So if my b would lie from minus 6 to minus 2 union 2 to 6, then only I will get my maximum value for fx at x equal to 1, otherwise not. Okay, so if you don't know how to solve this question, it's simple. Firstly, I am taking b square minus 4 greater than 0. From here, I am getting b minus 2, b plus 2 greater than 0. So from there, I am getting b belongs to this interval. And then I am solving b square less than 36. From there, I am getting b plus 6, b minus 6 less than 0. So from there, I am getting b belongs to minus 6 to 6. Taking intersection of these two intervals, that is from minus 6 to minus 2, union 2 to 6. So this is my b which I got from solving this equation. And for this b only, I can say that my function has a maximum value of x equal to 1. So I hope this was simple. Just you have to apply this logic that your function should have maximum value at f equal to 1. So f of 1 minus and f of 1 plus should be less than equal to f of 1. That's what I used there. And I used definition of f of 1 from the first definition because including sign is given here, not here. So I calculated f of 1 from here. I calculated f of 1 plus here, and I used this inequality and I got my final answer. Okay, so I hope you understood the entire concept of limits, continuity, and differentiability. It is one of the good chapters from mathematics. Like in JEE-Main also, they frame good type of questions from this chapter. So you need a definite amount of practice to get away with these questions. So I hope you understood rest all the questions which I told in this lecture. So now let's end this one. Okay, thank you.